Okay, let's take a look at an example we don't know how to solve by other means. This is a second degree linear differential equation, but it doesn't have constant coefficients. You can see I put a t in front of the y there. We know what to do. Of course, if the coefficients are constant, we find the characteristic polynomial and solve and go on by our usual techniques. But we haven't solved anything like this. Let's try it using the approach of power series. Now, before we do that, we do notice that this is a second order linear differential equation, and so we expect that the solution should have two parameters as opposed to our previous example, which was a first order linear differential equation, and the solution had only one parameter. That parameter we called A0. We could have called it C or capital A or whatever we want. But let's go ahead and try to solve this. Again, we will set y of t to be a power series. A0 plus A1t plus A2t squared plus A3t cubed plus A4t to the fourth plus on to infinitum. And we're going to need to take the second derivative. So y prime of t is going to be a1 plus 2a2t plus 3a3t squared plus 4a4t cubed plus and so on. And the second derivative, y double prime of t, so that goes away. We end up with 2a2 plus 3 times 2 or 6 a3 t plus the 3 comes down, so 4 times 3 a4t squared plus and so on. I might have to write a few more terms down here for us to get the idea. Now, y double prime minus ty equals 0. Let's just go ahead and put our y double prime and our y back into the original differential equation. If there was a space for the y prime, we'd put that in too, but there isn't. So we have, let's see, 2a2. Really, this is, of course, this is 2 times 1. I didn't write it that way, but now it looks more like the other terms. So 2 times 1 times a2 plus 3 times 2 times a3t plus 4 times 3 times a4t squared. Let me put in a couple more terms. Well, at least one more term. 5 times 4 times a5 t cubed plus and so on forever. So there's my y double prime minus t times y, which is nothing more than a0 plus a1t plus a2t squared plus a3t cubed plus and so on forever. And that's all supposed to equal 0. I remind you that the 0 on the right-hand side, we can think of that as 0 plus 0t plus 0t squared plus 0t cubed, and so on. We'll do that in the next step. But let's combine, well, actually, let's just do this multiplication first. So we'll rewrite this. 2 times 1 times a2 plus 3 times 2 times a3t plus 4 times 3 times a4t squared plus 5 times 4 times a5t cubed. I suppose the hardest part of this is your arm getting tired. Minus, we multiply the t in. What we have is a0 t plus a1t squared plus a2t cubed plus a3t to the fourth plus and so on. And that still equals 0. which is 0 plus 0t plus 0t squared plus 0t cubed. All we did here is multiply the t in. So t times a naught is a naught t. T times a1t is a1t squared, and so on forever. Now let's collect up like terms. So we have a constant term. Let's see. So 2a2, and we have a constant term here. We have no constant term there. So we have 2 times 1 times a2. That's my only constant term. And my linear term, the things with t's in it, are 3 times 2 times a3 minus a0 times t. So that's this term and this term, assuming I did everything correctly. And the next term is going to be my t squared term. So 4 times 3 times a4 minus a1 t squared. And the next term is going to be my t cubed terms. So 5 times 4 times a5 minus a2 times t, where are we, cubed. Let me put in one more term. The next term, even though I didn't write it over here, would be 6 times 5 times a6 minus a3 t to the 4th, plus and so on forever. And that equals 0, which is 0 plus 0t plus 0t squared plus 0t cubed, and so on. So again, as in the previous example, I have a list of equations. I basically have 2 times 1 times a2. My constant term over here has to be the same as my constant term over here, which is 0. So this equals 0. I have three times 2 times a3 minus a0 equals 0. I have 5 times 4 times a4 minus 5 times 4 times I left the turn out. Sorry about that. I have 4 times 3 times a4 minus a1 equals 0. I have 5 times 4 times a5 minus a2 equals 0. And I have one more, 6 times 5 times a6 minus a3 equals 0. We'll deal with that if we need to. I guess I have room to squeeze that in over here. And we really have infinitely many of these things. 6 times 5 times a6 minus a3 equals 0. I don't know if you can read that. Okay, so this first equation tells us that a2 is equal to 0. Once we know that A2 is equal to 0, looking down at this equation, we can see that A5 is going to be 0 because 20 times A5 minus A2 equals 0. So A5 has to be 0. And you can see that A8 is going to have to equal 0. So A2 is going to have to equal 0. A5 is going to have to equal 0. If we went down to 2 more equations, we see how A8 would be equal to 0. So A2 equals A5 equals A8. We're going up by 3 every time. The next one would be A11. All of these things are 0. So equals ... forever equals 0. All those things are 0. Once we know what A0 is, we can figure out what A3 is. We can see that A3 equals 1/6. If we bring the A0 over and divide by 3 times 2, equals 1/6 of A0. So it's A0 over 3 times 2. We can see that A6 is going to be 1/30th of A3. So A6 is going to be 1/30th of A3. So it's A3 divided by 6 times 5, which is just A0 divided by 6 times 5 times 3 times 2, whatever that is. 30, 90, 180. And once we have that in terms of A0, we can work out what A9 is going to be in terms of A0. We can work out what A12 is going to be in terms of A0, all the even multiples of 3. And going to this one, we can see that A4 is going to equal A1 over 12. We can see that the next one would be, let's see, would be A7. And the A7, we'd have a 7 times 6, A7 minus A4 equals 0. So A7 would be A4 divided by 7 times 6. And since A4 is just A1 over 4 times 3, we have that A7 is equal to A1 over 7 times 6 times 4 times 3. So we could use this to work out all the coefficients which are one more than an even multiple of 3 in terms of A1. So as we said in the beginning, we have 2 parameters. We can work out all the all the multiples of 3 coefficients just by using A0. We can work out all the one more than an even multiple of 3 by using A1. And so we have our solution to this differential equation. It is not in closed form. This does not give us a power series that we would easily recognize. But we could use these coefficients to figure out the value of y to whatever degree of accuracy we want by taking enough coefficients and then plugging in whatever t we want.